Hello friends, this video on integrals part 10 is brought to you by examfear.com. No more fear from exam. Before watching this video, please make sure that you have watched part 1 to part 9. We'll take some more examples. So here if you see we have sine ax plus b into cos ax plus b dx. Integral of this. So I have two options. I can take sine ax plus b as constant t, or I can take cos a as ax plus b as t. So let me take in this case, as I told, I can take this guy as t or this guy as t. So if I take any of these guys as t, what I get is sine ax plus b is equal to t. I get cos ax plus b into a dx is equal to dt. Correct? So if you see this guy is here, cos as plus b dx, this much guy is here. So this guy is nothing but dt by t. I'll take a here. So I can say that this equation is nothing sine ax plus b, the whole thing is t actually here, t into t, and cos ax plus b dx is nothing but dt by a. So a is anyway constant, this become t dt, and there is nothing but 1 by 2 t square by 2, 1 by 8 t square by 2. Correct? And now let me put the value of t. T is nothing but sine ax plus b whole square and plus some constant. Correct? So this was approach 1. Let's try to solve the same question. I'll just draw a line here. Now in this case I'll assume cos ax plus b as t. Cos ax plus b is equal to t. I'll get minus, if I differentiate both sides, I'll get minus sine ax plus b into a dx is equal to dt. So my sine ax plus b dx already I have. So I'll write, I want to find the value of this sine ax plus b dx. That is nothing but minus dt by a. So let's convert this equation. This becomes cos ax plus b is t into sine ax plus b into dx, that is minus dt by a, and that is nothing but dt by a. That is nothing but minus a into t dt, that is nothing but minus 1 by a t square by 2, and here t is nothing but cos a plus b, that is nothing but minus 1 by 2a into cos a plus b whole square, cos ax plus b whole square plus some constant, and that is my answer. So if you see, both are same actually. Let's take a third approach. In the third approach, what we can do, we know this is sine a into cos, sine, let's suppose sine k into cos k, they are same. So I can write this guy as nothing but, I'll write here sine ax plus b into cos ax plus b. I'll multiply and divide by 2 both sides. This is nothing but 2 sine theta cos theta, that is nothing but sine 2 theta, that is sine 2 ax plus 2b by 2. Correct? Integration dx. So in this case, let's assume this whole thing as t, that is 2 into ax plus b is equal to t. So I get 2a dx is equal to dt. Correct? So I'll get dx as dt by 2a. So I can write this guy as nothing but sine t, sine, this becomes sine t by 2 and dx is nothing but dt by 2a. So 1 by 4a constant I'll get 1 by 4a dx given integration and integration of sin t dt. This is also very simple for me to solve. This is nothing but 1 by 4t sin t becomes minus cos t plus cos t, and this is nothing but t is 2 of ax plus b, so this becomes minus 1 by 4a into cos of 2ax plus b plus sin. So you must be wondering, all these we got 3 different answers, but actually all 3 are same. If you see clearly, this is 1 by 2a into sine square ax plus b, and let me write everything in this fashion now. This guy, if I take, I'll write everything in this fashion. I'll just make it square now. This guy, let's take, this is nothing but minus 1 by 2a into cos square ax plus b. So what I'll do is, this is nothing but 1 by 2a is again a constant minus 1 by 2a cos square ax plus b plus some constant, because anyway this plus this is a constant only, so I can add or subtract some constant, because these equations are not exactly same, they are similar. That means you can add or subtract some constant. So this is constant, so this constant is nothing but 1 by 2a plus constant, because anyway you add subtract any constant, this is constant only, so I can write this constant as 1 by 2a plus constant. Why I am doing this? Because I wanted to convert everything into this fashion to prove you that all these 3 are similar equation. So this is nothing but 1 by 2a common, you will take 1 minus cos square ax plus b plus constant, and this is nothing but 1 by 2a sine square ax plus b plus. If you see this guy and these guy are exactly same, so this guy are exactly same. Similarly, in this case, cos 2ax plus b I can write as 2 cos square x, right, minus 1. I write this way. Let me write, I don't have space, so let me find a space to write. This guy only will be right here. This becomes 2 cos square ax plus b, because minus 1, correct. Cos 2ax plus b is nothing but, I'll write cos 2 theta is nothing but 2 cos square theta minus 1, because it is cos square theta minus sin square theta, or I can write this is 2 cos square theta minus 1, and the whole thing, if you see, is divided by minus 4a, correct. So if you see, this 2 and 4 cancel, so this becomes, this whole thing becomes, if you see, this becomes minus cos square ax plus b by 2a plus constant, because minus 1 by 2 is also constant. So if you see, this guy is nothing but this guy, same, second number, so both are same, and second one I have put as same as first one. That means all 3 are same actually. So you integrate using any way, you get same answer. All these functions are similar function, correct. Just the difference is some constant differs. Maybe here is k1, here it is k2, or here it is k3. The difference is in the constant, but the equation is all same. So in the first case, I assume cos x, sin ax plus bst. In second case, I used cos ax plus bst, and in third, I used ax plus bst. So in this case, all these 3 work for me. Why it worked for me? Because in all these 3 cases, I was able to reduce to a simpler form, t dt, and here sin t dt. Correct. So the reason why we use substitution is, you use any way you want, but you should be smart enough to use in such a way that your whole equation is simplified. Correct. So with this, I think you must have got a fair understanding of how to use substitution. So it is used to make my integral equation simple, to simplify the equation. So this was the complex one. I simplified it in this fashion, or in this fashion. Or I guess in this fashion to be more specific. So all these three, if you see, are simplified versions of the same function obtained using substitution. Thank you. Visit examfear.com to watch free educational videos, try free online tests, get the best quality study materials, study from the best tutors and mentors, and much more. Thanks once again.